let's do the antiderivative here. Notice that x squared is one kind of function, e to the x is a second kind of function. They're being multiplied. That tells you have to use integration by parts. We're going to go by isolate. That helps you to choose u. So u in this case, isolate says inverse trig. We don't have that. Logarithmic, we don't have that. A is for algebraic. We do have that. It's x squared. So this is x squared and need differentiate. So du here would be equal to 2x dx. That then tells you that dv is equal to e to the x and then dx. From here, what you have to do is you have to anti-differentiate. So anti-differentiate this side, anti-differentiate the e to the x dx. And when you do that here, it's going to give you that you have v is equal to e to the x. And then you plug this into the integration by parts formula. You're going to have, in other words, the antiderivative of x squared thus far, e to the x, and then dx would be equal to u times v. So that would be x squared e to the x, and then you're going to do minus the antiderivative of v du, so that would be 2x e to the x and then dx. From here you can say x squared e to the x and then minus 2 on the outside, antiderivative of x and then e raised to the x dx. X is one function, e to the x is a separate function. They're being multiplied. You have to do integration by parts again. So I'm going to do that off to the side. I'm going to do this part right here, antiderivative of x e raised to the x and dx. So here the same principle applies. You're going to say u by isolate equal to x. When you differentiate, it's going to be that du is equal to dx. That means then that dv has to be equal to e to the x and then dx. So anti-differentiate dv, and then also anti-differentiate here e to the x and then dx. When you do that, it's going to be that v is equal to e to the x, and then you plug back into the formula. So now this expression right here, u times v, so in our case that would be x times e to the x, and then after that would be minus the antiderivative of v du, which would be here e to the x and dx. That would just then become x e raised to the x and then minus e to the x this way. Go back over here, continue, it's going to be x squared e raised to the x minus 2, and then within brackets you can replace the integral with that expression. So x e raised to the x minus e to the x. Let me just kind of emphasize this. So this part right here, this red integral, this expression right here represents it. That's why right here is getting replaced. And then at the end you can attach a c, and then you can distribute the negative too. So it's x squared e to the x minus 2x e to the x, and then plus 2e raised to the x, and then plus c. And that's the answer. Please leave a like and subscribe. I'll see you in another video.